Good morning, madam. Myself, Savia. I am from CSC E section. Today, my topic is triple integral. Introduction to tetrahedron volume. The tetrahedron volume is a three-dimensional geometric shape with four triangular faces. Each face of a tetrahedron is formed by the intersection of a bounding planes. Understanding the volume calculation of a tetrahedron is essential in geometry and calculus. Applications of volume of tetrahedron. Integration. Tetrahedral volumes are used in triple integrals to calculate volumes of complex regions. Vector calculus. Gradient, divergence, and Creel operations involve tetrahedral volumes. Differential geometry. Tetrahedral volumes aid in studying curvature and surface area. Studying volume of tetrahedrons helps understand provide polyhedra. Let us see a problem of triple integral. Find the problem. Find the volume of a tetrahedron bounded by the plane x is equals to 0, y is equals to 0, z is equals to 0 and equation x by a plus y by b plus z by c equals to 1. Solution. The volume of a tetrahedron bounded by the planes x is equals to 0, y equals to 0, z equals to 0, x by a plus y by b plus z by c equals to 1 and can be found using triple integration. Given on the plane, equation x by a plus y by b plus z by c equals to 1. Limits. We have to set the limits. Z limits in terms of x and y. Z by c equals to 1 minus x by a minus y by b. Z equals to, here in c is dividing, it goes to left side, it can be multiplying. C equals to 1 minus x by a minus y by b. Now y limits. Y limits in terms of z equals to 0. Z equals to 0, substituting in equation 1, it becomes x by a plus y by b equals to 1. Y by b minus, here x by a is adding and it goes to right side, it can be subtracting. Y by b minus 1 minus x by a, y equals to b into 1 minus x by a. Now x limits, y and z equals to 0. Substituting y and z equals to 0 in equation 1, it becomes x by a equals to 1. That equals to x equals to a. Volume as a triple integral. Triple integral v dv equals to triple integral v dx dy dz. Z varies from 0 to c into 1 minus x by a minus y by b. Y varies from 0 to b into 1 minus x by a. X varies from 0 to a. Solution. Integration 0 to a, integration 0 to b, 1 minus x by a, 0, integration 0 to c, 1 minus x by a minus y by b, dz, dy, dx. We have to differentiate with respect to z. It becomes integration 0 to a, integration 0 to b into 1 minus x by a, z, applying limits, c into 1 minus x by a minus y by b dy dz. Integration 0 to a, integration 0 to b into 1 minus x by a, applying limits in z, c into 1 minus x by a minus y by b dy dz. Integration 0 to a, 0 to b, 1 minus x by a, 1 c into 1 minus x by a minus c by b into y dy. Differentiate with respect to y. Integration 0 to a, c into 1 minus x by a into y minus c by b y square by 2, applying limits 0 to b into 1 minus x by a dx. Integration 0 to a, c into 1 minus x by a b into y 1 minus x by a minus c by 2b b into 1 minus x by a whole square dx. Now calculating integration 0 to a bc into 1 minus x by a whole square minus bc by 2 1 minus x by a whole square dx. Now separating the main integration 0 to a 1 minus x by a whole square bc minus bc by 2 dx. Differentiating with respect to x, bc by 2 integration 0 to a minus x by a whole square dx. bc by 2a whole 2a square integration 0 to a minus x whole square dx. bc by 2a square integration 0 to a. Now applying a minus b whole square formula, a square plus b square minus 2ax dx. Differentiating with respect to x, bc by 2a square into 2 square x plus x cubed by 3 minus 2a x square by 2, applying limits 0 to a. Now substituting limits in x, bc by 2a square a cubed plus a cubed by 3 minus a cubed. Here removing a plus a cubed and minus a cubed. bc by 2a square into a cubed by 3, that equals to abc by 6. Thank you so much.